In this video, we're going to have a look at building lifting lugs into our models using the center of gravity tool inside of Inventor. Now, generally on a simple part like this, you just stick the lug in the middle, but in this example, we've got a nominal lug placed on the top of our part, and we've got our center of gravity now switched on. You'll see that there's a mismatch between them. And generally, if that lug already exists and you try and match them up, you're going to run into some trouble. So here we've done a measurement from the center point or our center of gravity to that outside flange, and we get a dimension of 25.5 and a little bit of change. And if we edit our dimension here to match that, we update it and we then re-enable our center of gravity, and we measure from our outside flange to the center of gravity again, you'll see that we're just about there, but there's a slight mismatch. So what do? Well, best practice is actually to just suppress that lifting lug, so we're just dealing with the original geometry, and to then do our measurement again. So from the center of gravity to the outside face, we now have a dimension of 25.511. So if we edit our dimension to 25.511 and we update our model, our lifting lug is going to appear in the middle, and then we update our center of gravity. Now, the reason this will work is because the lifting lug is exactly in the middle and our center of gravity now matches. So what happens if we then move into an assembly environment? So in an assembly, if we look at our center of gravity, it doesn't match our CAD model, our part model. So what we can do is a similar workflow. We can measure from the center of gravity of the assembly to our face on the flange, and we can then see we get a dimension of 37.024. And if we put that into our part model and we go back into our assembly, once we update our center of gravity, you'll see that we're now spot on. So those are two methods for looking at center of gravity within parts and within assemblies.